So, hello there. Uh, so today we will just go through the data science overall demo. It's more of a conversation that I wish to have regarding the course that I have designed and what is that you can expect out of this course. So I would be cutting down a lot of myths around data science as well, because I can understand it is with any new buzzword there will always be some sort of uh, misconceptions and untrue things which are already being spoken about in media. So I'll take this opportunity to explain what is actually data science is all about and what is reality, what are the facts, and what are just misconceptions. So before I delve into more into my slides about me, I'm Parag Pradhan, and I have around 13 years of experience in different domains such as BFSI, banking, finance, insurance sector, also in telecom sector. And over the last out of the 13 years, last 7 years have been predominantly into fields such as data mining, artificial intelligence, machine learning, and my previous experience was mainly with American banks, wherein I was involved in setting up teams for artificial intelligence, machine learning, as well as managing data scientists or machine learning engineers. So I do come with a background of uh, a practical exposure to what is really needed from data science as far as companies are concerned, because uh, data science is a field which has two types of connotations. One, data science as viewed from academics and as viewed from the corporate world, and there seems to be a gap between both the worlds. So even through my course I will be covering what is there in academics as well as what are the real expectations when it comes to data science on the ground, or as far as the expectations of the companies are concerned. So along with that, so that's more to do about me, and so I'll just quickly move on to my next slide, which is around data science. Like we've been hearing this word data, data, data. So what is data? So I have to put it across. Data is everything that we do. Even this conversation that I'm having right now, it is a data. The video, the audio, the slides, these are all data, and it was always there. I mean, it's not something it has happened overnight. It was always there with us ever since the mankind has evolved. Data has always been generated, but then why suddenly today we are talking about data science? If I just go back 20 years back, with the advent of social media, with the likes of Google, with the likes of Facebook, and most importantly the ease of computation that we have on our hand, which is our smartphones, this has actually given rise to emergence of tremendous amount of data that gets generated. And it all comes down to the organizations who are able to manage this data so that they can really make a difference as far as be it competitive edge in the market, or be it bringing out new products, or be it bringing out or identifying even certain risk factors in the market. So today we are in a situation which wasn't predicted 4 months back, but it has shaken up the overall economy. So this is where data comes into play, and because of the emergence of data, there is a acute need for people who can really work on data. When I say work on data, these are the individuals who can play with the data, who can extract meaningful patterns from a very, very, very complex data. Extraction of patterns is one thing, but extraction of meaningful patterns is another. And that is where the whole dearth of employees or resources is, that a new age of resources or new type of resources who can extract business driven decision making from the complex data which is currently surrounding every other organization. So then what skill sets we need to excel in data science? So if I look at those three boxes, we it does involve programming. I won't say it won't. So it does involve programming, but then we have always had programmers for last 30 years. So what's new? Uh, it needs a statistician or a background in mathematics, but then you know what? Statisticians have always been there around the corporate world for ages. And of course, we need the business SME. However, the current skill set which is needed to be a good data scientist or a good machine learning engineer is the one which I've shown in the bottom, a Sherlock Holmes. So if I talk about Sherlock Holmes, the key skill set of Sherlock Holmes is his curious mindset. Yes, that is the most important skill set that is needed to have a curious mindset. And of course, with the help of programming language, now there are a lot of I would say there are a lot of individuals or employees or employers who are not really open or exposed to a lot of programming languages. However, we are in a digital age wherein having at least a basic to intermediary understanding of a programming skill, even if it does not involve your day job, it is becoming a must. And soon there will be a situation wherein, like 20 years back, having an understanding of Microsoft Word and Microsoft Excel was optional, but later on it became a norm if someone wanted to get a job. We are almost facing a situation wherein there will be a situation wherein every resource, even if it is, let's say, someone who's going to work in marketing, someone's going to work in HR, someone who's going to work in product development, even those resources will be needed with some sort of background in programming. So it is a must for everyone to at least learn an intermediate level of programming. You need not be an expert, which is absolutely fine, but at least basic to intermediate level is very much important. And for the volume of data that we will be holding, it becomes mandatory that we need to use programming languages, because it's next to impossible to manage, let's say, a tons of millions of records in Excel sheets. We can't do that. So for that we need a programming language. So Python is a preferred programming language by most of the machine learning fraternity across the world. Then coming back to statistician. Now, what statistician has got to do with machine learning? So machine learning, I'll be touching base upon what is machine learning soon, but machine learning essentially are mathematical models or mathematical equations which are used for extraction of patterns from data. And then, of course, having an understanding of what kind of data it is, this is where having a bit of an understanding of business will always help. So I'm not a doctor, but if I'm working on images of, let's say, cancerous cells, if I'm trying to extract some patterns, it's always necessary that or it's always beneficial for me to have little bit understanding of the domain that I'm working on. So data science essentially requires a combination of all these three skill sets, be it programming, be it a statistician, and be that of a business SME. And this is where I feel the whole job market or role is evolving. Uh, we have always had just a programmer, we have always had just a statistician, and we always had just a business SME or a subject matter expert. But now there is a need for someone who is a blend of all three. Okay. So this is just a way to show, as a proof, as that data science is something which is talked about everywhere. Everybody's speaking about it. So if I look at the last top 10 skill sets for 2020 and even 2019, you would find Python as a programming language, which is being ranked very highly as something which is being needed by most. Uh, if I look at machine learning is another skill set which is being talked about, which has been really in high demand in the market. And it will continue to grow, because this is where, with the advent of data, we cannot run away or escape from skill sets which are needed to extract patterns from data, which essentially is machine learning. And these are like some of the frameworks in machine learning that are very popular, something like TensorFlow, Google's TensorFlow, or building a chatbot. I'm sure we all at some point these days interact with a chatbot. We may not even know that there is not a human across the platform, but there is a chatbot, be it your banking queries, be it your uh, parcel queries or any e-commerce queries, invariably you would be interacting with a chatbot. And of course, then we have the cloud, because there is no end to the amount of computation that we can do. And because of that, having on-premises hardware such as servers or even your regular workstations will always have a kind of an hindrance or an obstacle when it comes to computation of large scale or humongous volume of data. That's where moving on to cloud or having an understanding of cloud becomes very key important. And then the last snapshot is mainly to explain some of the key technical frameworks or programming languages as needed to really excel in data science. Um, Data science as a field is very vast. It all comes down to where we start. And if I have to give my own example, as I said, like I've been in this field for last 7 years now, wherein I've built a team. I have learned from scratch. I got into machine learning and data science, wherein back in 2012, wherein I couldn't find anybody here in India at least who had an idea of what this field is all about. So it was more of my own experiences of several times doing a lot of things incorrectly, but then as I matured and grew and had a clearer understanding of the subject, uh, there is definitely a possibility that someone might start at wrong places. And as I said, it's an ocean. The subject is an ocean. If you can plan it properly, strategize it properly, and narrow down your focus area, that is the right way of really getting into machine learning. So I'll talk more about it in the course that I've designed specifically for those who have zero clue of what data science is, but is looking forward to it as a stepping stone in their career. All right, so this is just a voice of industry I've tried to capture here, and the most important box for me on this slide is the last one. These days, if you interact with any CXOs, be it the CTO, CIO, or even for that matter, CEO or CEO of any organization, they will be talking about machine learning, data science, and artificial intelligence. So why is it so important that suddenly everybody is talking about it? And the reason to it, and this is what in so this is a question even I'm trying to decipher for last 7 to 8 years. Automation industry, the way it has grown over the last 20 years, it has done fantastic or fabulously well when it comes to automating tasks which are rule based. So when I say rule based, means there is a specific way of doing it and there may not be any variation whatsoever. So such tasks have already been automated, but then there is next level of task wherein we need some sort of subjective decision making. Now, when it comes to subjective decision making, that's when rules will not really help you. So, if I have to give you one example, if you receive an email, you read the body of the email. This is the body of the email. There are certain tasks that you decide. Now, the body of the email will keep on changing. So you cannot come up with a specific rule that if my body of email consists of these words, then do this, then do this, then do this, because there is infinite amount of possibilities what kind of emails that you would receive that would trigger you to take certain decisions. So this is where machine learning as a next layer or as a next level of intelligence for the machines, so that even these tasks now can be automated. So quick snapshot of the course that I cover. And so I've broken down my course into three broad segments: data science 101, data science 102, ML in production, and social profile. So starting with data science 101. So as I said, my focus of the course is not to bog you down with a lot of theory, because as I said, there are two paths one can pick up when it comes to data science or machine learning for that matter. One is an academic route. Then if you want to do that, I always recommend someone to get into the proper academic circles for this course. And even I have done that. So I took a year break and I went back, did my master's, but not not immediately when you're already into a job, like 4 or 5 years down the line. Moving into a university may not be, it may not be possible for everyone. So if not that, then the second route is sticking to your existing jobs, existing roles, and how can you further enhance or value add your existing profiles. So my course is for the second kind of people, participants who are looking to enhance their existing roles. However, they do not have any understanding or background in data science. So I start my data science 101 with linear algebra. Yes, it is the same subject that we hated, or most of us, including me, hated back in school days. Uh, well, I mean, that's a that's a thing in past. But linear algebra is something which is very important. So when I talk about linear algebra, just to give you an exact idea, matrices, does it ring a word? Yes, matrices, vectors. So these are the backbone of machine learning algorithms, machine learning algorithms or machine learning equations. So I do cover, so I start my sessions with a very, very, very fundamental refresher on linear algebra. Once that is done, we move on to Python programming language. That is the preferred programming language for the course. So again, in Python, there are multiple learning paths that one can choose for. So if you're looking for a web development, so then there is a different path. If you're looking for more of a machine learning data analysis, there is a different path. So the path that I will be covering is mainly around data analysis and machine learning using Python. So in case someone doesn't have a programming background, I start from basic, and I will only be covering Python that much which is needed for machine learning. But I always give it up, or I always give it back to the participants who are interested to further learn. I mean, there is no end to what else you can learn or what more you can learn, but there is a specific amount of knowledge which is bare minimum needed. That is what I generally cover as a Python. Then we move on to the algorithms. This is where the whole magic starts. So what are algorithms? I'm sure if any of you into computer science, you would know it better because I come from mechanical engineering background. Yes, I'm not a computer science graduate, but I'm a mechanical engineer. So algorithms, if I translate into more of practical approach or practical situation, these are step-by-step approaches which are used to solve a problem. Now, machine learning algorithms are essentially equations. These are mathematical equations which are used to extract patterns, extract relationships among whom, if you recollect, we in school we had a very weird looking equation called as y is equal to f of x, wherein y becomes our target variable or the information that we are interested in. Let's say y could be your weather, what would be my temperature, and f of x, wherein f means relationship. What is the relationship of temperature, of my day temperature, and x could be your humidity, could be your pollution levels, it could be the month of the year. So basis these parameters, your temperature is basically decided. So there is a relationship between this. So essentially machine learning tries to find out such kind of relationships within your data without being told what the relationship is. And this is where this extra added intelligence for these algorithms comes in. We users, or as a ML engineers, we do not provide the exact relationship, or we do not provide a rule for what, whenever we have a month and a humidity, how is that correlated to a temperature. Rather, the equations that we use, they identify this relationship between your humidity, your month of the year, the pollution level, with your day temperature. So this relationship is extracted using the equations. So some of these machine learning algorithms that I generally cover, these are the foundations of the whole machine learning gambit or the subject. Linear regression analysis, logistic regression analysis. So these are the, like, probably the grandfathers or grandparents of any machine learning, for any machine learning course. So it's a must that one should be comfortable as far as their theoretical working is concerned. So I will be covering a theoretical aspects of how linear regression analysis works, how logistic regression analysis works. This is where having a basic understanding of how matrix calculation works will be really helpful, which I cover as a first session of the course. Then decision trees and random forests. These are tree-based algorithms, another very powerful machine learning algorithm which is used for identifying patterns from the data, which is also commonly used for a lot of predictions. K-means clustering, hierarchical clustering. So clustering are a set of algorithms which are commonly used to extract clusters or groups within the data. For example, if you have a e-retail or e-commerce data for consumers who have bought product for last 1 year, let's say you have 1 million consumers and you have certain variables or certain parameters or certain information about the consumers, be it their age, be it their whether they are from metro city, non-metro city, maybe their an estimate of annual income, their genders. Using that, many a times, a lot of organizations create clusters. Now, these clusters are nothing but groups to study such a huge data rather than studying individual customer. We would break it down into certain groups, maybe like a group of 5 or 7, and we study these groups individually or separately. And how do we do that? So there are algorithms who are used commonly, such as k-means clustering, hierarchical clustering, which are used to identify these groups. And basically, we study the behavior of the group. And using that behavior, many times a lot of organizations plan their product release or product development. So even for that purpose, this is how data is used in driving business decision making. Then we move on to association rule mining, which is a very common algorithm used for predicting commonly occurring events. The classic example is supermarket. So if someone walks into a supermarket and looks at a bread, you might end up seeing that there is a butter and milk also kept very next to each other. The reason is there are good chances that historically the shopkeeper might have seen that whenever a person purchases bread, they also purchase butter and they also purchase milk. So association rule mining tries to extract occurrences of events or occurrences of sale that occurs in conjunction or they occur in combination of one another. So such patterns are commonly used, especially in supermarket placement of their products. And then the last piece I would be covering under Data Science 101 is recommendation engines. Well, the easiest example is to, if you right now go on to your Netflix, Hulu, or your YouTube, you would find a lot of recommendations. Now, these recommendations are driven by several algorithms. So I cover some of the most commonly used algorithms, such as collaborative filtering, singular value decomposition. So these are like some of the most commonly used algorithms, which tries to identify what kind of, let's say, movies or what kind of uh, products one would be interested in. So I'm sure you would have also experienced this in Amazon. So if you try and purchase a product, it will definitely show you a group of products saying that people who bought this, they also bought 1, 2, 3, 4, 5, and then we end up purchasing much more than we really needed. And then the last piece is called as hyperparameter tuning. So once we build an algorithm, it goes through an iterative process till we reach the expected level of accuracy. So expected level of prediction or expected level of performance of the algorithm. So just like driving a car, if you drive very fast, your fuel consumption will be very high. So if you want to save your fuel consumption, you would reduce your speed, but then you would end up reaching everywhere very late. So you try to identify a common path or a very optimum way of driving, such that your fuel consumption is also limited and you also do not end up reaching late. So this is nothing but you're trying to optimize the behavior of your driving. Similarly, we will try to optimize. So every algorithm, as I said, algorithm is nothing but an equation. There are a lot of assumptions behind every equation. There are a lot of parameters that impact an equation. So we try to tweak these multiple parameters in such a way that the performance that we get is that of optimum level. And then there are some basic strategies which are commonly used. So I cover them under hyperparameter tuning. At the end of every session, there will be a lot of assignments. These assignments come from these data sets are all real world data sets. The place that I use or the portal that I use for datasets is kaggle.com. So I'll be talking more about it in the social profiles. Then moving on to data science 102, text mining. So text mining, data today does not just mean your numbers, it also means text. So extracting patterns from text is, I consider it to be a completely different new science altogether. It needs a little bit different treatment, like as compared to your regular numerical values. So data science 102 deals with how do we manage text related data. That could be comments, that could be feedbacks, that could be um, extracting information from multiple books or multiple write-ups. So there is a flow, something called as natural language processing. So natural language processing is nothing but a science or a computational science which deals in extracting patterns from text-based data. So we will go through some of the most commonly used techniques when we work on text. Then there are certain machine learning algorithms which tend to work well, especially in a text mining kind of a scenario. So I will be covering them specifically in text mining, such as naive-based classifier, support vector machines. Topic modeling is another very important algorithm which is used to extract topics from a huge corpus of text, and something called as TF-IDF models. Then again, use cases. So as I earlier mentioned, we use real world data sets such as BBC dataset, which is a very commonly being used across a lot of academic circles. Then certain emails. So we will be building an email classifier which will predict whether a given email is a genuine email or a spam email. We would also be building a small POC around search engine. How does the search engine really works? So you would type your query and you would get your results back. And then there are several review data sets coming from Amazon or basis certain drug or medicinal review data sets. So we will try and extract sentiments from these text as well. So this is what all comes under text mining. Then moving into the last piece, which is the ML in production. Now, machine learning in production is a topic which need not necessarily be covered in data science. It's not data science per se, but today it is very much important that once your model is built, how does your model become available to the rest of the application development team? So for example, if you're part of a team that's building a health app and you have a machine learning model that predicts the health of a human basis, his daily parameters, daily values. However, that model is only as good as the user is able to get some output from your model. And between that, the user will have an app. So you will need an Android developer or an iOS developer. So ML in production is where I cover a very small topic in which how, even as a machine learning engineer, you can make your model available through something called as API or accessible programming interface, so that other developers or other programmers who are building, let's say, the UI or the backend of the application can utilize your machine learning model. And this is where the ML comes into its life. So I do cover it, but again, it's not something I cover extensively because it will need some sort of web development background as well. So I just cover what is there, and if in case someone is interested, they can always further explore it. Uh, Another last piece, which is a social profile. It is, having knowledge or having an experience of a specific topic is one thing, but today we live in the age of digital world, social media era. So it is very much important that to be really attractive as a towards any employer. Many of the good organizations have started to really look forward to your social profile. Your social profile, I do not mean the likes of Facebook and Instagram, but something like GitHub. Now, GitHub is a place wherein it's a code repository. Whatever codes that you work on, it can be made. It's like a cloud for your cloud codes where you can store your codes. Others can collaborate on your code. At the same time, it also becomes like your portfolio or a profile wherein recruiters can see the kind of work that you have done. I mean, you won't find a better way to really showcase your skills than GitHub and Kaggle.com. So Kaggle is a website. So maybe I'll just quickly show you what Kaggle is. So this is the Kaggle website. So from this website is what we'll be using the data sets for the course. So Kaggle is it's a public portal wherein you would find amazing data sets coming from. So as you could see, data sets on COVID, data sets on movies from Netflix, you would find African wildfire, you would find lots of data sets. And you would find data sets, you name it, and you would find a specific kind of data set. So you can experiment on explore using these data sets. At the same time, the benefit of Kaggle is you also get to see what others are doing on it. So it's like a collaborative community wherein you share your solutions, others can comment on your solution, you can see what others are doing that. So by that, I see twofold benefits. One, you're creating your profile. Every time you try and solve one of these data sets, it reflects in your profile. So it's like your own portfolio. And the second benefit is you improve your knowledge when you get to see what others are doing, what kind of techniques they are using, what kind of knowledge, or what kind of algorithms they are using. You inherently or you start absorbing those concepts and those knowledge as well. So this is why Kaggle is very important. And as I said, GitHub. So as a recruiter, it's a public platform. Whatever assignments, whatever tasks that you do, whatever practice data sets that you use from Kaggle, it's a good practice to create your portfolio. This becomes your resume. This becomes your portfolio, and you won't find any other better portfolio than Kaggle and GitHub. So this is where I come to the point saying that building a social profile. So my focus during the session would be how do we build a social profile in such a way that the participants are able to also create their profiles which are attractive to recruiters as well. So my focus, as I said, from start to end is going to be on the practical implementations of the algorithms, enough theory that is needed for you to get started, and a good amount of focus on how you can build your social profile. So it goes hand in hand. So with that, so these are like some of the industry applications that I have to just name a few, and I'm sure many of you would have been already exposed to some of these applications, be it like natural language processing. So natural language processing, as I said, it's a science that deals with extraction of information from text-based data. Some of the examples are like sentiment analysis of Twitter data, or prediction of ratings. This is the user feedback. Then event prediction, like prediction of share values, house price prediction, and then there is this like the more advanced use case for machine learning, which is called as deep learning. However, I will not be covering deep learning in this existing course. So this course is more like a foundational course, which gives you a start and an intermediary update information around machine learning. But as a next step, once you are comfortable with machine learning, then the next logical progression will be into deep learning. So these are complex algorithms which are modeled around or loosely modeled around how our brain works. And just to give you one example, these days if you take a photograph and if you try and upload it on Facebook, Facebook starts tagging names of individuals in your photo. It could be your friends, your colleagues. This is where deep learning comes into play, and that's the next level of intelligence that the scientists or the academicians and industry is looking forward to. However, a word of caution, in the current scenario where we are, especially in the current Asian markets, a lot of organizations are still struggling to figure out what needs to be done using machine learning, because all of this depends on data, and a lot of the organizations are still struggling to figure out how do they manage their data, store their data, and what to do with it. So even with a good background in machine learning can be a very good start. Then one can advance more into a deep learning course as well. So this is just a snapshot of the job market which is there. And I need not further elaborate, but if I talk more about job market, especially in India, it's it's going to be a very niche role, however, a role which every organization these days wants. Just as an example, and this is where I think, we all have the power of digital world. Try and Google on any of the job sites, just try and put the words ML, machine learning, data science, and you would come to know the kind of jobs which are open. However, even if that is the case, the other problem is skilled resources are less. There are people who undergo trainings. There are people who undergo trainings on writing programming code for data science, but that is not data science. So if you really want to excel as a data science professional or want to make a career in this field, you need to be cognizant of the fact that it is not just a programming, it is not just a mathematics, it is not just business. It's a combination of three. And that is why it needs dedication towards the course. The course that we have it will be going for 2 to 2.5 months every weekend, and it's generally for 8 weeks, but I've seen that it invariably goes for close to 10 weeks or so, because that includes refreshers. Many a times participants want to go for a new subject altogether, because as we talk, someone somewhere is coming up with a new algorithm. So post the foundational sessions on the data science 101, 102, I also cover some aspects of deep learning, more like an basic understanding of what is there next. However, my expectation from participants is, especially for those who are working or in a working profiles or with some experience, you need to invest 25 minutes a day, which is 125 minutes or 120 minutes roughly a week. That is the bare minimum expectation as far as solving the problems. I will also be giving a lot of, after end of every sessions, I will be sharing a lot of links for reading, for blogs. So this is how you will also actively increase your learning, because learning doesn't mean you will be sitting in front of me, I will be explaining. Well, honestly, that never gives you the feeling of learning. You grow, substantially grow, when you sit, absorb what you have, what you would, from the sessions that I cover, and go back, go through the links that I've given, go through the assignment that I've given. That is the time when your absorption rate will be at its peak. So that is a key part of my sessions, that I always request my candidates that if you cannot spend 120 minutes a week, now 120 minutes a week is 20 minutes a day, 25 minutes a day, please, then this course is not meant for you. Because after a couple of weeks, if you haven't done your uh, assignments, if you haven't gone through the blogs that I share, it will become very difficult, it will become very overwhelming for you to even cover up on most of the sessions. uh, so it is important that you should have your timetable ready, that 20 minutes a day is what I'm asking for. It's not very exorbitant, it's not like a couple of hours a day. 20 minutes, I'm sure we all can figure it out. In case those who are freshers or have maybe a year or two experience, I would recommend them to spend much more than just 20 minutes. If you're a complete fresher, be prepared. Be prepared. It's not going to be like, sessions wherein you would come, go through my sessions, go. This is not a college. I cannot be your teacher at this age, but my role will be to facilitate. My role will be to share the right way of doing things. There are mistakes that I did because I initially started as a self-learned individual in this field. So I will be sharing what you should be doing and what you shouldn't be doing. So if you are a fresher, be prepared to at least spend a couple of hours a day. If you can't, please do not get into in no, please do not get into this field. This is a demanding field as far as knowledge is concerned. You'll have to have knowledge of programming, you'll have to have knowledge of mathematics, you will also have to have knowledge of a good marketing skill, because your algorithm is only good as good as you can sell it to the main business individuals or group of individuals who will utilize it and then take decisions, or maybe utilize it as a strategic initiative. So you need to be good at marketing as well. Okay, so coming to the an important segment is certification. What certifications are there? Honestly, if you ask me, there are best certification you could get is your Kaggle profile and your GitHub profile. If you are able to showcase close to 25, 30 problems being solved on Kaggle, that is your best certification. Similar codes, if you have on GitHub for those 30, 25, 30 odd problems that you have solved, that becomes your certification plus your resume. However, I will recommend Dell EMC Squares. It's a globally recognized certification. However, even on their website, they mention it that you would need around 150 to 200 hours of self-study. So this is my own experience. I think I needed close to 250 hours to go through the entire syllabus. So that's, if you're looking for a certification per se, this is what you should be targeting. But be sure, please be assured that you need at least 200 hours of investment when it comes to really cracking such certifications. And there are lots of centers as far as EMC Square authorized centers are concerned in Pune. At least I'm aware of 30 plus centers, so that shouldn't be a problem. However, even if you do not want to go through a certification route, uh, with the whole mindset change in the job market is not just your certification, or not even your certification anymore, but it is what you have done. And this is where again I'll go back to my point of GitHub and Kaggle becomes really important, because this is where the recruiters can actually see what you have done. And this is the mindset change that is happening. And I think this is where you should be focusing more. So these are like some of the FAQs that if I talk about, let's say, if someone's fresher, can they get into data science? Yes, they can. And this is where your uh, portfolio that you would be building on Kaggle and GitHub will be of importance. Then let's look at a situation wherein someone is already 8+ years of experience in a completely different field, and if they want to move into data science, do they need to start from scratch? Well, no, not necessarily, because whatever experience that you have, it just cannot go away like that. So you will always have that extra bit of maturity of working in groups, working in an organization, which will always be always be very helpful. Then there is another approach to it. You need not leave your existing job or your existing profile, but you can enhance it. So as I said, data science is more of data driven decision making. Let's say someone could be working in procurement. So using some of the machine learning algorithms, you could come up with a better way of predicting or forecasting the products that you need to purchase beforehand. So that way you can still utilize machine learning and data science to enhance your existing roles. Now, one more question that I generally, get from a lot of participants, that's if someone's not working on data science, how can they prove their knowledge to a recruiter? The answer is same, GitHub and Kaggle. That is your portfolio. That is your experience letter for the recruiter. So you need not worry even if you are not into data science or ML as a field. And again, you won't find a lot of people who are working in data science and ML because it's still a very new, very niche field. So you would have people coming from different backgrounds, not necessarily having professional experience in data science and ML, but then again, you can show your professional experience basis the Kaggle and your GitHub, so your programming codes and solutions on GitHub. Let's say someone doesn't come from a non-technical background. So can they excel in this? And the answer is yes, you can. And as I said, these days, you could be a painter, you could be an artist. But if you want to excel, it's required that you need to have a bare minimum understanding of programming language. Again, Python needed, that is which is required for machine learning, is not very extensive as compared to web development or maybe backend development. And on top of it, Python as it is very simple as compared to other programming language. It is not very verbose. The learning curve is also very less. So, and somewhere that is also one of the reasons that people who started, or the whole community of machine learning, is geared towards Python as compared to other programming languages. So I think even a non-technical person can really make a mark in this field. And then how many hours do I need? So I've already given an idea about how much time investment is needed. So if you are already into a job with and considering your hectic schedules, 2 hours per week is what I look forward to from working professionals. Either you do it in a weekend or 20-25 minutes on a daily basis is what I would highly recommend. And especially those who are freshers, I request at least 1 hour a day or up to 8 to 10 hours a week is what my expectation will be, considering the overall syllabus that we have. All right, so with that, maybe I can just quickly show you guys, the power of machine learning with a very simple topic. Yeah. So I'll try and predict shares. Again, I do not come from share market. I've got nothing to do with share market. It's just an example that let's say I do not have a clue of shares. I'll try and show using linear regression how close the prediction is to the actual value of share values of an organization. So this is what this is the uh, application. It's called a Jupyter notebook, which we will be utilizing for writing our Python codes. The best part of Jupyter notebook is it's like any other notebook, the ones we would have used in schools and colleges. You could write your codes, and we could also get to see the output of the codes immediately below it. So it becomes easier for running experiments and trying out different things. So this is just a flow of how a machine learning model is built. It's typically built on historical data. Then there's a step called as feature engineering. Feature engineering is nothing but, maybe in a very simplistic way, what you could think of. Let's say in an Excel sheet, if there are blank values in your data, at times you either remove the entire row or you decide to add maybe average of the entire row in your blank values. So this is what we generally call as feature engineering. Once that is done, we split our data into three different parts. The larger chunk, around 70% of data, we keep it for training. This is where we will be using machine learning model or algorithms to learn patterns from data. Then we put it on, we test it on a set of data that we had already curled out separately, verify the results. Basis the results, if we need to tweak the values or if you want to further improve the accuracy, then there is a method called as hyperparameter tuning, by which we will tune different knobs of our algorithm. And once that is done, we are comfortable with it, the machine learning model is pushed into production. So I'm sure this image, we all must have seen it in our school or college days. Linear regression, equation of line, if you recollect, We had this in school, y is equal to mx plus c. So wherein m is nothing but your slope of the line and c is the constant. So if I bring the same equation for, let's say, this is x could be the square feet of a house and y could be the prices of the house, and the dots are nothing but the actual values being plotted. So a line is drawn which represents the relationship between the x and the y. The slope or slope b1 is where the actual machine learning happens. Now let's say if we have let me just, let's see if there are more data points. I start adding new data points. So there is new set of data that gets added. So rather than this line, a better line that will represent the relationship between y and x could be drawn something like maybe like this. So now the actual slope or the entire slope has changed from this angle B1 to this angle B2. So this change in line or change in slope is what we call it as machine learning, because the algorithm automatically changes its parameters of equation. This b1 will change, and it changes basis to reflect the relationship between y and x. So this is what we call it as a machine learning. Yeah. So uh, so I'll try and predict the closure prices of the stock market. Let's not worry about what these weird looking lines of codes is. This is what I will be covering in the sessions. Okay, so let's look at the graph. The yellow ones are the actual share prices, and the blue ones is the predicted value as compared to the yellow ones. Now, if you see, even using a simple linear regression, I haven't done much of a complicated task. With just few lines of codes, few lines of Python codes, and using linear regression as an equation, using this equation, you could have ended up making some money with it. It's quite close by. So this is the real power of machine learning. And with that, I hope if you have any questions, you guys can always reach out to us. But I wish you all the luck for the journey in machine learning. It's a very, very interesting field, but it's a field that involves a lot of dedication, lot of studies. Be prepared to burn the midnight oil, especially if you're freshers and moving into data science. Be ready to burn a lot of midnight oil, and I wish you all the luck. Thank you.